today is day 1 of conic sections, meaning we are cutting part of a cone by a plane to form different shapes. The first one we are looking at is a parabola, and in this case we're going to be looking at a parabola in kind of a different context than we did earlier in the year. And in this case we're going to be looking at it as the set of all points that are equidistant from both the line called the directrix and the point called the focus. So in these parabolas we're making, distance D1 and D2 are the same. So let's analyze some new terms and information. We are going to be looking at both vertical and horizontal parabolas. So a vertical parabola will open either up or down. We'll have our focus, which is offset from the vertex by this distance P, and we will have our directrix, which is also offset from the vertex by that same distance P. So for a vertical parabola, our directrix is a horizontal line, and then the axis of symmetry is a vertical line. In a horizontal parabola, we're opening either left or right. We still have our focus, which is offset from the vertex by that distance P, and then the directrix offset from the vertex by that same distance P. Our directrix is a vertical line, and our axis of symmetry is a horizontal line, okay? So the focus is always inside the parabola, and the directrix is always outside. The parabola will never touch or cross the directrix. And then our directrix and axis of symmetry are perpendicular, and then that vertex is the absolute value of P away from the vertex and the directrix. And we'll talk about why we used absolute value there in a moment, because P can sometimes be negative. So what does this mean as far as equations go? So the standard form for the equation of a parabola is as such for a vertical and then a horizontal parabola, where our vertex is HK, and then P, again, is that distance between the vertex and the focus, and the vertex and the directrix. So when P is positive in a vertical parabola, we're opening up. When it's negative, we're opening down. When P is positive in a horizontal parabola, we are opening to the right, and when it's negative, we're opening to the left. So with all of that information, and if you need to pause that to fill it in, go ahead. We are going to be graphing parabolas using these steps. We are first going to write the equation in standard form if necessary. We're going to graph the vertex, determine what direction it's opening after we find P, and then from there we can plot both the focus and the directrix, and then sketch our parabola. So let's get started. On number 1, we are going to be graphing each parabola. So what I'm going to do is write the equations for the parabolas up at the top so I don't have to flip back and forth. So this is for a vertical parabola. And this is for a horizontal parabola. So I'm going to have those up at the top for reference. So starting with number 1, the first thing we can identify is that this is going to be a vertical parabola because of the formatting of the equation. We have x squared. So the next thing we're going to identify is the vertex. I don't have anything being added or subtracted on my x or my y, so that tells me that my vertex is at 0, 0, and you can go ahead and plot that. The next thing I need to find is what P is, because P is going to tell me where to draw my directrix, my focus, and it's going to tell me what direction my parabola is opening. So remember, 4P is what's being multiplied by the y in this equation. So negative 8 is equal to 4P, which if I divide by 4 on both sides means that P is negative 2. And because it's negative and I have a vertical parabola, that means I'm opening down. So if this is my vertex, my focus is going to be 2 down from there. So my focus is at 0, negative 2. And then my directrix is going to be up 2, and because it's vertical, it's going to be that horizontal line at y equals positive 2. Okay. So the axis of symmetry here is along the vertex, and so that's going to be the y-axis, or the vertical line, y equals 0. And now I'm just going to draw that parabola that opens down. Okay? I'm not going to be focusing too much on how wide or narrow or how pretty your parabola looks. What I want to look at is the vertex, focus, directrix, and that your parabola is in the correct direction. Other than that, I'm not going to be super picky. All right, let's look again now at number 2. This is a horizontal parabola. We know that because we have y squared. Again, I don't have anything being added or subtracted on my x or my y, so that tells me that my vertex is 0, 0. Now, I want to find P. This 6 value is equal to 4 times p. So if I divide by 4 on both sides, that means that p is going to be 3/2, which is a positive number. And because it's a horizontal parabola, that means that this is going to be opening to the right. So my focus is going to be 1.5 units to the right. And my directrix is going to be 1.5 units to the left, and it's going to be that vertical line here. So that focus is at 3/2, 0. My directrix is at x equals -3/2. My axis of symmetry for this parabola is the x-axis, or the horizontal line y equals 0. And I'm just going to draw a parabola open to the right. On to number 3. We again have a horizontal parabola. And this time I do have a vertex that's not at the origin. My x value for my vertex is 3, my y value is 2, so that vertex is going to be at 3, 2, which you can go ahead and plot. Now I need to determine what direction it's open. So if -4 is equal to 4p, that means that p is -1, so it is going to be open to the left because it's a horizontal parabola. So my focus is going to be 1 unit to the left, and my directrix is going to be 1 unit to the right, and it's going to be that vertical line. So our focus is at 2, 2. Our directrix is at x equals 4, and our axis of symmetry here is going to be this horizontal line at y equals 2. So again, drawing my parabola now, open to the left. All right, and then on to number 4. Again, we do have a vertex that's not at the center. That vertex is going to be at -1, -2. And this is a vertical parabola. So if 14 is equal to 4p, that means that p is 7/2, which is positive. So this parabola is going to be open up. So here's my vertex. So my focus is going to be 7/2, which is 3.5 units above my vertex. So let's plot that. 1, 2, 3.5. Eyeballing it, those coordinates are -1, 3/2. And then my directrix is going to be 3.5 below. 1, 2, 3.5. And it's this horizontal line, which is at y equals -11/2. And the axis of symmetry here is this vertical line, x equals -1. And I draw my parabola opening upwards. Okay. Not too bad. Now we are going to be talking about writing the equations for a parabola given different sets of information. So first of all, let's recall the correct format for writing these equations. For a vertical, x minus h squared equals 4p times y minus k. And for a horizontal, they are flip-flopped. Y minus k squared equals 4p times x minus h, where hk is your vertex, and the absolute value of p is the distance from the vertex to the focus and from the vertex to the directrix. So the information we need is, one, is it horizontal or vertical parabola? We need to know the vertex, and we need to know what p is. All of that information is necessary to write these equations. So let's start here at number 1. This is a vertical parabola being opened upwards, and here my vertex is given to me. That vertex is at the point 0, 5. And here the focus is 2 away from my vertex. So that means that p is 2. So vertical parabola, open up, here's my vertex and p. So I'm going to plug those values into my equation. X minus 0 is just x, so x squared is going to be equal to 4 times 2 is 8, y minus 5. Okay, not too bad. Let's look at number 2. Again, this is a horizontal parabola open to the left. I'm given my vertex here, and it is at 3, -2. And our focus is 5 away, and because it's open to the left, it's going to be negative. So here's p, here's my vertex. Let's plug it into our horizontal parabola. So that's going to be y plus 2, because minus a negative is plus, equals -20, x minus 3. And that kind of went off the side. Okay. So then on 3 and 4, we are given the vertex and the directrix. So horizontal parabola open to the right. My vertex, we're told here, is at -6, 1, and the directrix is 1 away. So that means that P is 1. So plugging this into my horizontal equation, easy peasy. All right, and then last one of this kind, here our vertex on this vertical parabola open down is at -4, -5. And our directrix, if we count, it is 10 away. So that means that P is -10 because, again, it's open down. So x plus 4 squared is equal to -40 times y plus 5. Sorry, my y looks kind of funny there. That's y plus 5. Okay. So that's when we have a graph. Well, what if we're given the vertex and the focus? Well, again, we're given the vertex, so that's h and k. What we need still is to determine, is this a vertical or horizontal parabola, and what is P? So let's look at 5. If this is HK and my focus is at 0, 4, that means that my vertex is going to be here, my focus is going to be here. So this is a vertical parabola open up, and it's 4 away, so that means P is 4. So x squared is equal to 16y, okay? And 6 is another easy one where the vertex is at the origin, so I'm going to skip ahead actually to number 7. Again, we're given the vertex, HK. I need to determine what P is. So, again, let's do a rough sketch. If my vertex is at -7, 1, and my focus is at -7, 3/4, that's just below it, that means that this is a parabola that's being opened downward. And the distance here between the focus and the vertex from 1 to 3/4 is 1/4. And it's open down, which means it's going to be negative. So again, HK, vertical parabola, open down. P is -1/4. That's going to give us x plus 7 squared equals -1 times y minus 1. All right. Now, what if we are given the vertex and the directrix? Again, on 9 and 10, the vertex is at the center, so those are pretty easy. I want to look at 11 and 12. Vertex, directrix. So here's HK. We need to know P. So if my directrix here, this is a vertical line, that means that my parabola is horizontal. It's open left or right. So I need to figure out how far apart 7 is from that 3/2. And that is going to be 11/2. So plugging this into my horizontal equation, 11/2 times 4 is 22. All right. Number 12. Again, here's HK. If my directrix is a horizontal line, that means this is a vertical parabola. So I need to look at the difference in my y values, and that is going to be 7. And it's open upwards, so it's positive. So plugging this into my vertical equation, there we go. The last type we're going to be looking at is when we have the focus and the directrix. And again, I'm going to skip 13, 14 because the vertex is at the center, at the origin. So again, we need to find the vertex and we need to find P. So if this is my focus and this is my directrix. Again, if you need to do a quick sketch, that's totally fine. So if my focus is at -8, 5, and I have a directrix, a vertical line at +4, that tells me that this is going to be a horizontal parabola open to the left somewhere. So my vertex is going to be halfway between this focus and this directrix. So looking at my changes in my x's, from -8 to 4, that is 12. So there's 6 apart from each, that vertex is. So P is going to be -6 because it's open to the left. And 6 away here, my y value is not going to change. And I'm going to end up at -2, 5. So that equation, or that horizontal parabola open to the left, is as such. All right, one more. Again, we have the focus and the directrix. If I do a quick sketch, here is my focus. There's my directrix. This is a vertical parabola open down. Look at my changes in my y's. From -3/2 to -1/2, that is a difference of -1/2. And so P is 1/2. The vertex is going to be in between at -4, -1. And so that equation for that vertical parabola open down is as such. And you can check your answers by graphing from your final equation.